So, welcome everybody. So, first of all, I would like to thank the organizers for having me here. It's really a pleasure. As I said, I'm not used to microphones. Okay. So in this talk, I will just want to give you, to explain a very common Git experience, that is how to solve conflicts. So it will be like a continuation of the talk by Filippo of yesterday. So let me start by by recalling what is the situation. So remember that now this is what happens when we want to contribute to Mathlib. So we want to propose like a new theorem to Mathlib, or maybe fix a small error like we did yesterday. So remember that the picture is as follows. So you have to think that there are 3 repositories, so 3 copies of Mathlib. There is Mathlib, the official one, okay, that everybody uses. Now there is my repository online, that is the fork that we created yesterday at the beginning, and then there is my copy, the copy of my computer. Okay, so these are 3 different repositories. They can talk to each other, but they are very different. So I put arrows here, meaning that, for example, these 2 repositories can talk in both directions. So if there is a modification here, I can pull the modification to my computer. So this is the Git terminology. So it means that the modification done here get copied to the modification to my computer. And I can also push the modification in the other direction. So I modify a file on my computer and I push it to my remote repository. Okay? Of course, I can pull modification from Mathlib. Someone proves the Riemann hypothesis. We want to have the Riemann hypothesis on our computer. Okay? But you see that there is no arrow in the other direction, because we cannot directly push to the main repository. Okay? Of course, I can also put a new modification in the official one to my remote repository, and I can somehow try to push. If there is a modification here, I can open a pull request to get the modification accepted here. This is why the arrow is in another color, because the white arrows you can just type push, git push or git pull. This one, it means that you have to open a pull request. Okay. So now so Git is the software that allows you to do all of that. So the important thing to understand is that Git is a very complicated software. There is no need to really become a Git expert. As you can see, this happens all the time to everybody, essentially. You have just to learn a little bit how it works, but it is worth to spend like 5 minutes a week, and after 1 month, you got used to it. And sometimes it's still problematic, but it's not that difficult to do the usual pull, push, open a pull request. The first time it looks like a complete mess, but after some time it gets quite quick and quite easy. So let me go to the. So this is the guy that Filippo showed yesterday. I just followed it line by line this morning, especially if you use what is called option A. That is what I did this morning. Everything works really out of the box. I just copy paste these comments to my computer, and everything worked perfectly. So now you have exactly that situation. And let's suppose that you did some work. So for example, this is my DS code, and you see that here I'm in a branch. So remember that when you start working, since maybe you want to add theorem A, but also theorem B, so we want to prove Riemann hypothesis and Fermat's theorem, but you don't want to mix these 2 results, because who knows, maybe you will finish Fermat's theorem before Riemann hypothesis. So you work in 2 branches. It means that this is the work I'm done for Fermat's theorem, and this is the work I'm doing for Riemann hypothesis. So I create the branch that is called RB/Kummer again. The name doesn't matter. Choose the name you want. So RB is because it's my branch, but there is no need to use this convention. You can call whatever you want. And you prove your new theorem, or you fix some modification in Mathlib. So this is the file I was working on. It doesn't matter. It's a file in number theory. It absolutely doesn't matter. So I proved my theorem, let's say last week. This is a new theorem that I added. I think it's this one. again, the actual theorem doesn't matter. So I proved this. I was happy about it, and so I opened the pull request. Again, following exactly the guide here. So, and this is the pull request. So you see that, for example, you can have a look at the file changed tab to see what is the addition I made. So you see that, okay, I had to add something at the beginning of the file. I had a small documentation, and then I actually added the theorem. Okay, so it's where it is. Here it is. So this is the theorem I want to add to Mathlib. Okay. So far so good. This is the normal workflow. Is this clear for everybody? This is exactly what I'm going to explain today. So this is a standard workflow. Now, Mathlib gets updated like literally 20 to 30 times a day. So Mathlib, all the various files in Mathlib get modified every single day. You see, this is a modification to a file called class number.lin. If someone has modified, I don't know, group theory.lin, who cares? These two files are separate, and Git is smart enough to handle this thing. So Git will still realize that I just modified another file, so I'm still proposing to just add this new theorem. So there is no need to care about the fact that someone has modified another file. And you just ignore this. And you open your pull request and you wait for a review. So you see here, there are a couple of comments. So the comments looks a little bit weird because it's actually a pull request that I transformed from the previous system, but forget about it. You see that there are comments by Filippo and someone else. So I got a comment, I addressed the comments and so on, and the pull request is still there. So no one approved it. And at some point, this label appeared, merge conflict. So I hope that you also get an email when this label gets added, but this is maybe not working today, but it will work next week, hopefully. What does it mean? So imagine that now someone else actually, for example, you see that here, I'm fixing some documentation. Okay? I mean, I'm fixing this line. This line already exists, and I'm modifying this to this. Imagine that someone else in the meantime also modified this line to something else. Well, now Git cannot understand what I want to do because Git knows that I wanted to replace this one by this one. But this one does not exist anymore in current Mathlib. Okay? So Git now says, okay, now I don't understand what you are proposing. Because so someone has modified exactly the thing you are also modifying. And so Git says, I don't know what to do. Is this clear? So it's just that in the meantime, so this pull request has been open maybe for 3 weeks. And in these 3 weeks, someone else opened another pull request that for some reason got accepted before mine. Maybe because it was smaller, maybe because it was better, who knows? But this, in practice, this happened. And now it's not clear what I want to do. Because I don't want the file to become this, because maybe someone else added another theorem. So I want to keep also the theorem added by the other person. So this is essentially what a merge conflict is. It just means that someone has modified the same file you want to modify, and Git is confused. Git is relatively smart, so it really means that we modify the same lines. So if you add the theorem at the end and someone add the theorem at the beginning, Git is able to handle this. So it's pretty smart. So, but sometimes it really says, I don't know what to do. Okay, and this is what merge conflict means. So how do we fix this? Well, I want to see exactly. You can see that at the end of the pull request, there is this branch has conflict that must be resolved. So it means that Git doesn't know how to merge this pull request. Merge is the process of moving from here to here. Okay, so what we want to do, to see this conflict. So here, the conflict is something that is happening at the level of this arrow. So my repo is perfectly fine because it's not synchronized with this one, because the Mathlib that I had here is the Mathlib of 3 weeks ago when I opened the pull request. So first of all, what I need to do is to use this arrow to get a very recent copy of Mathlib, so I can compare this new one with my modification. And if you look at the guide, in the part daily workflow, there is this thing. So git switch master says, okay, now let's go. So I'm here because I'm working on my computer. Let's go to the master branch of Mathlib. So git switch master, and you see that he say your branch is behind upstream master by 251 commits. Because in the meantime, since I opened the pull request, Mathlib has been modified 251 times. But usually you can ignore this. Okay, but now I have to get this modification. So the command is to pull. At some point you get used to this terminology. I'm using this arrow. So I just do git pull. Okay, who knows? So this is the list of files that has been modified. You don't need to care about it. So now it means that the master branch here is in sync with the master branch here. Okay. Still, my other branch is still perfectly fine because I didn't touch it. Okay. So my branch I was working on here is still perfectly fine. It is incompatible with master, but you can still work on it if you want. So what I want to do is to merge the master branch here to my branch here. So I can go to my branch, that is git switch. Okay, so now I went to my branch. So you see that it says your branch is updated with origin former again. So origin is this thing, and it says that these two branches are equal here and here. Sure. Yeah. So this is a good question. It's slightly technical because there is if you follow the official guide, the master branch is different. There is this is what you get if you follow the official branch. So the master branch here is set up to get in sync with this one. So when you are on master and you write git pull, it takes the master branch from here. But usually for all other branches, this is the conversation that happens. Why this is the point? Because essentially the master branch here is completely useless. Maybe it does not exist. It doesn't even exist. I don't know. Anyway, it's useless because you never want to create a branch called master here. So you have a master here, and no master here. Here you have a working branch that is also here, and you open the pull request with respect to this branch. Okay. Yeah. So the situation is like that. If you have computer 2, you No. Never use your master branch. You don't want to touch. No. That's important. The master branch. So for other branches, yes, but the synchronization happens because essentially, if you work at the end of the day, you push what you did. So at the end of the day, you keep your computer in sync with the remote one. So you are at the office, you work a little bit, you say, okay, now I'm done for the day. You push here. Then the day after, you wake up and you say, today I work from home, so use another computer. And the first thing you do is you pull. the modification you did yesterday. But you still work on your working branch. Yeah, because at the end of the day, you pushed the working branch from computer 2 to GitHub. And the beginning on the next day, you pull the same branch from GitHub to computer 1. No. This is clearly explained in the guide. So when you want to work on Mathlib, you create. So let's suppose you want to prove Fermat's theorem. You create a branch called Fermat's theorem. Maybe you also want to work on Riemann hypothesis. So you have also a branch called the Riemann hypothesis. You never work on master. Master is needed only to do this thing. Why this is the point? Because here there is only one branch. Again, this is a lie, but let's suppose that it's like that. Here there is only the master branch. That is the official one. And so what you say when creating a pull request means you ask to merge your working branch to the master branch here. Don't use the same name, otherwise it's maybe confusing. But so you never work on master, you only work on Fermat's theorem or Riemann hypothesis. You get, every time you stop working, you sync your work with the remote things. And if you change laptop, if you change computer, just pull. Okay, so now where I am, okay, now so I'm here on my working branch. And now since GitHub is telling me, well, there is something incompatible with master, what I did is I updated the master here from here. And now I do git merge master. So this means include the modification made in master to my branch. For example, if someone has modified a file I'm not working on, this will happen very smoothly. I don't see any, I mean, Git will take care of it. It will modify this file. But here I will pop, I guess I will have an error. Exactly, you see what it says? Auto merging, blah, 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 failed. So all the other files are now updated as they should be in my working branch. But this one is saying, I don't know what to do. I'm not able to do it. This is why you got this email saying there is a conflict in your branch. No, it's very different. So pull means please synchronize my computer with what it is online. So when you say, when you are working on, for example, you can do on any branch. Pull means you pull from online. Merge means, so essentially you only do merge master. This is the, I mean, of course you can do whatever you want, but this is the main action. So master has been modified by someone else in the meantime, because someone else opened another PR that got accepted, and so the master here has been modified. So what I'm doing is that, first of all, I update my master here from this master, and then I merge the modification that have been done to master to my branch. Yes, yes. You can also directly merge a remote branch, but first of all, you have to tell Git to realize that the branch has been modified. So it's better to follow this workflow.
But if you're correct to say that when you do git push, you say that you have two branches, that you have two sets on two different computers, or two sets of files that are supposed to coincide. And when you do git push, you say makes the other one on the other.
Yeah.
Coincide with my copy, and when you say git pull, they make the remote copy make your local copy coincide with the remote one. So when you say git merge, you have two different nodes, and you say make them.
So really, I think that the easiest way is to keep these actions very, very separated. You can mix them a little bit, but so there is pull that every time you are at every moment you are working on your computer. At every given moment you are on a branch. Again, I know this is false, but let's ignore this. So at any moment you are on a branch. When you say git pull, it means please look at the branch. So the branch here and pull the modification that someone else did, maybe you with another computer, who knows, to my actual computer. If you do git push, is the opposite. So you push the modification you did here to here. Okay, the master branch has a special rule. Git pull and push are exactly the same thing. And push you cannot do, but git pull, you don't pull from here, but you pull from here. This is a special rule for master. Okay, so pull and push are pretty straightforward, I would say. They are used to keep in sync your computer with the remote version you have, and in the two directions. In VS Code, if you click on the little circle that is in the left bottom, it does git pull and git push at the same time. Now, git merge is something else. You merge one branch into another. What does it mean? So any branch knows what has been so let me say, a branch contains a list of modifications that have been done when you start working on this branch. So for example, I am in the branch Fermat's theorem when I'm improving Fermat's theorem. Well, I did it. I also finished my work on Riemann hypothesis in the branch Riemann hypothesis. Okay. Now I would say, well, let's just put everything together. So I want that my work on Riemann hypothesis get also included in my branch called Fermat's theorem. So I merge the branch Riemann hypothesis to the branch Fermat's theorem. And to do this, I have to go on the branch Fermat's theorem. That is this git switch name of the branch, and then you see you do git merge the other branch. In this case, what I'm doing is I want to include that is the thing maybe the only case where you really want to do merge is I want to merge the modification that someone else made to master here to my working branch here. So you see, there is one further step. I cannot, if I just merge master here, nothing happened because the master here, it's not in sync with the master here automatically. So this is why at some point I did this git switch master. I hope I didn't mess up everything. Ooh. Okay, because now I am in the touched state. Oh, sorry. No, I hope. Okay, let's see what happened. But at worst, I will reclone everything, doing exactly what AKCD is suggesting. No, so what I did before. No, okay, maybe not, but we'll see. So what I did before is I switched to the master branch here. I pulled the modification. So now the master branch here is actually equal to the master branch here. And now I try to include the modification that someone else did to Mathlib in my working branch. This is all useful to resolve conflict, but also maybe you are proving a theorem, but you are waiting for, you need a result, and you know that someone else is working on this result. At some point, this result by someone else gets accepted into Mathlib, so you want it now. But you cannot use it because your branch was created 3 weeks ago when this result did not exist. So now to include it, you do exactly this. Sometimes it works perfectly. Sometimes it gives you problems. Problems means that Git is not able to mix the modification you did and the modification that someone else did. And this is why we got this conflict, blah, blah, blah. So let's see how to solve it. There are, of course, like a lot of ways. You can do it in VS Code. So let's just open VS Code. Okay, so this I was in the file that I was modifying, and you see that here there is this strange output. This is the merge editor thing. So is the VS Code trying to help you to understand what's happened. So let's see. It's not. It takes a little bit of time to take care. So what he's saying is that the problem is here. this is the part that Git was not able to understand what to do. So you see that, remember that I also added the theorem like at the end of the file, but Git say, okay, that's fine. I understand what I have to do with that one. Nobody touched, I mean, that's completely clear. But I modified the documentation, and also someone else modified the documentation. And there it's really confusing. So you see that there is this head current change. So this is what I am proposing. And this is what actually so now Mathlib is like that. And this is what I am proposing. And I think that so Git is not able anymore to know what to do. So do I want that this line became exactly this or this one? This is up to me. In this case, I think that I just want my new modification to, because it's a doc string, so it's. But imagine that maybe you generalize the theorem from I don't know, field to I don't know, skew field, and someone else generalized. So you replace the word field with skew field, and the theorem still worked. Nice. You generalize the theorem, why not? But someone else modified the same theorem from field to ring. Well, in that case, you want to keep the other modification because it's better, of course. So, yeah. I mean, everything is possible, but there is no perfect solution. I mean, the point that you have really to have a look and see what's going on. There is no perfect solution because two persons modified the same line essentially. So you have to look. So what I want, you can also try compare change, but this is even less readable if you are not used to what a diff is. So here is really trying to show me next the modification one next to the other. It's usually not that. I mean, if you at some point you get used to it, but I think that this is. Oops, sorry, this is pretty clear. So you see. There is this line, cardinality of the class group of its ring of integers. So this line is the same. And now I am proposing this theorem, blah, 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 with this doc string. And here there is this other doc string with, you see, essentially the difference, I think, is that here the Minkowski bound, that is this complicated number, is spelled out explicitly. And in my modification, I start here with the note by MK the Minkowski bound. That is probably a good idea because this number is repeated like 5 times in the file, so it's very long, so it's better to give it a name. So what I want to do is I want to keep this one. So I do accept current change. And you see that the other one disappeared. Again, so there are 2 simple solutions. It is keep your modification, keep the other modification, or you can do whatever you want. You can keep both of them. You can keep part of one, part of the other, but that's up to you. Yeah.
There was another modification that after a dot in the list, there is a typesetting rule that you have to indent everything.
No, but this is. Yeah, but okay, okay. You spot it. Okay.
Try to understand what would be.
Yeah. That's probably the. Yeah. Okay. Yeah. This is why I got confused. Yes. Thanks. This is why I got confused. So you see that this has been modified with an indentation, and I'm modifying the file, but without adding the indentation. So Git cannot realize that, okay, he has to replace this by MK and indent it. I mean, this would be too much. So, okay, now we completely understood what's going on. So what I can do, I still accept my thing, and now I indent it as it should be. So what's the point? Everything should be indented like that. Why is it not working? Why it doesn't work? Ah, okay, sorry. Okay. Yeah. I mean, I will fix this. I will seriously fix it. But you see that now. So I realized what the other person did. So I kept my modification, but also what the other person did by hand. And okay, sometimes it's painful, so, but that's the point. So now you save the file, you go here, you just forget about these 2000s, blah, blah, blah. You just click on stage and continue. Okay, now you see that there are no more conflicts, so you can push. You can just do, for example, git push if you want. Sorry, this is just me being paranoid. So you feel free to push, and you cannot. I'm paranoid because I can push to master here. So every time I push, I check that I'm on the right branch because I don't want to destroy the official. I mean, I think I set up my computer to not do it, but I want to check it. Okay, so now I resolve the conflict here and I pushed here. So if I go to the pull request, the conflict should have gone. Okay. You see that here there is a new commit. So it says that I merge the master branch into my branch. And in like maybe 10 minutes, a bot will remove the label automatically. But if you go down, oh, it's already done. Yeah, okay. Here. Okay. You see, now there are no more conflicts. And now, so your pull request, now it's updated with the latest Mathlib, and there are no more conflicts. You maybe you want a double check to see that nothing strange happened. This is maybe a good thing. Let's see here on what's modified, if it's still good. I mean, okay, you can have a look at, you can read this to check that it's good, but the theorem is still there. So now everything looks fine. Okay. So now my pull request, it's already ready to be reviewed because it doesn't have conflicts, and we'll see. Maybe someone will review it today. I don't know. No, it's no problem. Okay. So it doesn't happen very often to have a conflict. It really depends on which file you work on. Of course, if you create your new file about I don't know, blah blah, Zumaya, skew algebra, or whatever it is, and nobody is working on that, this never happens. This never happens. So, but if you modified some basic file because you need a stupid lemma about groups that for some reason nobody added it, it's possible that you get this conflict. Okay. Yes.
So I noticed you made a commit from within VS Code, but then you switched to the terminal to do the push, right?
Yeah, this is because you can also you can do it in VS Code. Yeah, just where if you because I'm also yeah, in this case it surely works. You can always do that. So if you click here, you see it say synchronize changes. It does pull and push at the same time. Yes, in resolving conflict, I prefer to do it on the command line because I have more control. But if you did everything correctly, VS Code works perfectly fine.
You didn't do the on the command line, so could you have just saved the file and then switch to terminal and then like?
Yeah, I had to commit.
Yeah.
Git commit, blah blah blah. Yes. Yeah. This is the I mean, this is the usual Git workflow is still applies. So you have to stage, commit, push. Okay. So now something else in the last 5 minutes that I think it's important to mention. So you see that now VS Code is not working. You see, there is this red line that is probably not a good sign. No. What's going on? So what's going on is the following. So now I modified essentially everything in Mathlib because I merged what people did on Mathlib in the last 3 weeks or even more. So now Mathlib is very different from 3 weeks ago. Maybe someone changed the modification of the definition of groups. Who knows? I don't think so, but some very basic file surely has been modified. And so now, to start working, my computer should recompile all Mathlib from the beginning. And this is something very time consuming. So we made up, I mean, we created a system to solve that, so that there are computers that create compiling Mathlib somewhere else in the world, and you can download a pre-compiled version of the Mathlib of your branch. So, and this is done by Lake Exe get. So this will be very fast, don't worry. If you are wondering why this pre-compiled thing is not part of the GitHub, why cannot just do git pull and get it? Well, because GitHub will kick us out if we start putting 3 gigabytes of things in the repo for every branch, especially. But you see that it's downloading a lot of files that some computer somewhere in the world compiled for us, and in 1 minute it will be finished. If I have to compile everything, my computer is a normal laptop. It takes like 2 hours, 2 or maybe even 3 hours. I don't know. So it's something very time consuming. And this also happening. This also happens if you, for example, modify a very basic file because you want to add a new small lemma about groups, and then you want to use, and then you say, okay, I did it. Let's use it in a file about the Riemann hypothesis. Well, there are a lot of files in between, of course, and so Lean needs to recompile everything. So what you can do is you commit the modification to the group file, you push it, you wait half an hour, you go to have a coffee or something like that, and then you download the cache. Of course, if you don't think about it, it's very annoying, because if 5 seconds later you say, oh no, I have to add also another theorem, then you also have to wait. So what you can do is just, you can put your, another way of working is to put your theorem in the file about the Riemann hypothesis, even if it's a theorem about groups, and at the very end, put it in the right place. Because in Mathlib, we want results in the right place. So, but you can worry about it at the end. So now I guess that if I open VS Code, the red line should go away. Yeah. Oh, okay. Let's see. You see that now Mathlib Lean is working, and there is a linter. So I made a small mistake in the modification. This PR will not pass continuous integration, meaning that you see that I don't have everything green here. And because it spotted this error, so here, Lean should tell me what the error is. And it is a warning, it's not an error. So this line exceeds the 100 character limits, okay? Because, oh, you see what happened? That since I indented two spaces, now this is the 100. No, but it happens. And when Lean was not working, I didn't see it. But so let's just fix it. It's not the most fun thing to do, but okay, now it's done. Now I can also commit this. So I stage it. Long line. I don't know why I have 2 times the thing, but okay, and I can push it. And now here you see there should be another commit called the long line. Here it is. And now continuous integration is restarting, but you will see that the first one that is just checking the format, indentation and stuff like that will pass very quickly. Okay. Again, I know that at the beginning it seems like a lot of things to do, but they are almost always the same thing. So something that you should understand is you should not be afraid of committing like every 10 seconds. It doesn't matter. So even if you only add a small lemma, and here VS Code, GitHub says something like that you want to merge, where is it? Yeah, it wants to merge 11 commits. don't worry if here he says that you want to merge 3,000 commits. We don't care. So meaning that you are not at the end, this will be forgotten. So the bot we spoke about yesterday, boss, the terminology is squash, so you will transform your 3,000 commits in only one commit that will have as message the title of your PR. So this is why the title is slightly important. So don't be afraid of doing commit all the time, because this is the way you can go back. If you do a modification and you don't commit it, Git will not help you in going back. So don't be afraid of having 300 branches. Branches are very, very cheap as spaces on disk. So, and with a lot of commits, if you do that all the time, Git will work pretty well. At the beginning, it's still a little bit confusing, but don't worry, you will get used to it. I mean, we were all there, and at some point we got used to it. Of course, Git is a very powerful software. So if you are curious, you can take any tutorial online and reading how it actually works. Not how it actually works, but what really merged means and what are the other actions you can do. But if you look, you can do a lot of stuff with Git, but this is essentially on the thing you need to know. And you can do almost everything with VS Code. And maybe my last suggestion is install in VS Code this pull request, GitHub pull request extension that helps you to see your pull request. You see, I click here, he knows that this branch is related to a pull request. And here I just see the file that I modified, and it gives me also the same view as before. So maybe, I mean, it's a useful extension to have. If you install an extension, you just go here and you type GitHub pull request. Yeah, something like that. Okay, I think I stop here. Maybe one last thing. Sorry, maybe we should check that the modification we did yesterday works. No. Yeah.
Questions, comments? We're all going to be deleting our branches and just starting.
Maybe there's something imagine you do a bad merge. You believe that you have to keep the first and you have merged.
No. You can do everything. The point, you do a bad merge, so you have to you go. So what a Git repo is essentially a tree of commits. So you have commit 1, 2, 3, and maybe here this is a merge commit. So it means that this is branch A, and here you also have branch B, and here you merge branch B into branch A. So this is A plus B now. And if you want to revert this is just a normal commit. You go back to commit 3, for example, and yeah, you did it. It was a bad merge, but yeah. So yeah. No. Okay. Yeah, but, I mean, you can still modify. I mean, force push or whatever. But yeah, of course, I mean, things can become very complicated easily. But in principle, you can solve essentially everything. The point that, seriously, I mean, it's not a joke. Sometimes fixing the thing is so time consuming that it's easier to clone a new thing, especially if you still have your modification is 50 lines, just copy these 50 lines somewhere else and you start again. I mean, this is some sort of a joke, but sometimes rather than spending 15 minutes in doing the right Git thing, just do that and who cares. The important thing to know is that you cannot, the nice thing of Git is that if you push to your repo, you cannot lose work. So your remote, unless you do this force push, that it means erase from the thing here. But if you push every time you do, if you commit and you push every time you do something, your work will never be lost. So this is the nice thing of Git. Maybe you are not able to find it, but then the solution is just go to Zulip and ask someone. Okay, yesterday my PR was at a good point. Now I messed up things. I know how to solve it, and people can access to your GitHub, to remote GitHub, and so they can fix it.
And one more comment.
Sure.
LLMs are really good at Git.
Yeah, that's true. That's true. That LLM are good because especially now that our setup is the standard one, they are very good. Yeah.
I think we have a coffee break, and then we're free to work on projects. Those that are contributing to the number theory project, can we meet here at 11 to do a little bit of big picture and check in on everybody? Because most of the texts are done, and so there's a little bit of cleanup I had to do this morning.